Okay, circle theorem question. There are a few things you should ask yourself with a circle theorem question. Is the center clearly marked? Is there a tangent? Are there 4 points on the circumference? And are there angles in the same segment? Okay, those are just the 4 main questions you should ask yourself when looking at a circle theorem question. Clearly, there's no tangent, so that's straight out. The center is not clearly marked. Now, that'll come back to us in the last part of the question. But if the center is clearly marked, then you've got things like the tangent and the radius being 90 degrees. You've got the angle at the center, subtended at the center being double the angle subtended at the circumference. You've also got isosceles triangles, because if you know where the center is, then you can mark off all the radii and the triangles with radii, and then we'll make isosceles triangles. But there's no center. There are 4 points on the circumference. When you see 4 points on the circumference, you should immediately think cyclic quadrilateral. Cyclic quadrilateral means that if you've got 4 points on the circumference, that makes a quadrilateral. The angles on the opposite corners of the quadrilateral will add up to 180 degrees. So that's key one. And angles in the same segment. If you can see lots of crisscrossing going on, that means you can pick any 2 points, let's say D and C, and any angles that they make at the circumference. So D, C make an angle here, B, which is 55. That's going to be the same as any other angle D and C make at the circumference. So that means that that one over here is going to be 55 as well. And similarly, we can see that this is 40. That's come from C and B. So C and B also make an angle here, which has to be 40 as well. We'll come back to those in a second. First thing it says is angle DAC. Now DAC we just worked out, that's 55, and that's because the angle's in the same segment. That's the blue rule here. So DBC is 55. And that has to be the same as DAC. DCB, right, now this is a bit more tricky. That's, if I get rid of all this. Sorry. No, that's 55. Now, DCB is the angle here. And because we've got the 4 points on the circumference, we can look at the angle opposite and see if that helps us. Well, that angle is 40 plus 55. So if that total angle is 95, then it's going to be 180 minus 95, which is 85. So the reason for that is cyclic quadrilateral. Opposite angles. Total 180. Now that reason gets you 1 mark. The angle gets you 1 mark. But you'll notice it's a 3-mark question, so it actually wants you to justify it very slightly. You could just say BAD equals 95. BAC, sorry, BAD, the angle, equals 95 degrees. So DCB equals 180 minus 95 equals 85 degrees. And there's your 3 marks. Is BD a diameter of the circle? Well, if DBD were a diameter of the circle, then it would subtend a right angle at the circumference. That's very important. So that would mean that, taking a look at the top again, if it subtends a right angle at the circumference, that means that the angle it makes at the circumference here should be 90 degrees, and that angle should be 90 degrees. But we already know from the last part of the question that this angle here is 95 in total, and this angle here is 85. So clearly it doesn't make 90 degrees at the circumference. If it doesn't subtend 90 degrees at the circumference, it can't be a diameter. So the answer is no, and the reason, which gets you the mark, is that diameter subtends 90 degrees, and BAD or BCD equals 95 degrees. That's the basic reasoning.